is Monica, and I'm teaching as an assistant professor in ABES Engineering College, Ghaziabad. Today, we are going to discuss the topic 01 Knapsack that is based on the concept of dynamic programming, where we use the result of the solved subproblem in solving the another subproblem. Now, moving on to the question. So, the question is for the given set of items, the knapsack capacity having 8 kg, find the optimal solution for 01 knapsack problem making use of dynamic approach. Here we have 4 items having weights respectively and profits respectively. For this, we have to make a grid consisting of rows and columns, where rows represents the item and columns represents the total capacity, starting from 0 to 4 and 0 to 8. CI represents the profit of a particular item. WI represents the weight of a particular item. First of all, make the starting rows and the columns to be 0. Next, we have to select the first item and then first item weight is 2. So we have to find out a column having 2 kg weight, So we'll put the profit 1 in that particular 2 kg. This. So in the first part, we have included the first item having the profit 1 and weight 2. So we'll repeat this 0 value in this particular cell, and we have only single item selected so far. So 1 will be repeated from 3 to 8 kgs as we have only capacity of 2 kg in an 8 kg knapsack. So next is selecting the item 2. When we select an item 2, it has a profit of 2 and weight 3. So we'll go to third column and put the profit 2 over there. Now we'll find out the combination of these two weights. So selecting first and second item together, the weight is 2 plus 3, that is 5, and the profit is 1 plus 2, that is 3. So we will put 3 in the column 5. Now repeating the value from the above cell, that is 0 and 1 will be repeated in the C21 and C22, and in C24 we'll be writing 2 as it is, that is horizontally, and 3 will be moved on same till 8. Now selecting the third item. When the third item is selected, we have a weight of 4 kg and a profit of 5. So we'll go to the 4 kg column and put the profit 5 over there. So now finding out the combination of these three particular items, where first of all we'll check 4 plus 3 is 7, that is including the second and the third item. So the profit is 5 plus 2 7. So in 7 kg column, I am going to write the profit 7. Now, or other combination is if we are selecting third item and the first item, that is 4 plus 2 is 6 and the profit value is 6, 5. So we have written 6 over here. Other is 5. So we cannot get any combination of 5 over here. If I select all the three weights, that is 4 plus 3 plus 2, that is 7 plus 2 is 9. So I'll exceed the total capacity, which is 8. So I'll avoid that particular combination and repeat the values 0, 1, 2 from above cell, and 5 would be repeated horizontally and 7 would be repeated horizontally. Now selecting the fourth item. For fourth item, I have a weight of 5 kg. So put a 5 kg weight having a profit of 6. The first values are repeated from the upper cell, that is 0, 1, 2 and 5. So finding out the combination of these four items, if 5 plus 4 is 9, if you are selecting a fourth item and third item, the weight is 9. So 9 is exceeding the total capacity, so we ignore this combination. Now selecting an item 4 and an item 2. The weight is 5 plus 3, 8, and the profit value is 2 plus 6, 8. So in 8 column, we'll write a value 8, and upper values will be repeated here. 6 would be repeated here. Now next would be the combination of another value, that is 7. Will we get any combination of 7? Yes, we can get a combination of 7 also by selecting an item 4 and an item 1. So weight value is 5 plus 2 is 7 and profit value is 6 plus 1, 7. So we'll write 7 over here. Now Calculating this particular value using a particular formula where C represents the particular matrix, I represents the rows, and J represents the column. So maximum of C I minus 1 comma J comma C of I minus 1 comma J minus Wi plus Vi, where Wi represents the weight of a particular value and Vi represents that is the profit of a particular value or a particular item. So if we are calculating the value of, say suppose I am calculating this value 2. That is, I have selected a row 2 and column 3. That means I is equal to 2 and J is equal to 3. So C 2 minus 1 is 1 and J is 3. So we have to find out the value of C23. C23 is C23 we have to find out. Now putting it in the formula, C of I minus 1, that is 2 minus 1 is 1 and J is 3. That is we have to find out the value of C13. 13 is 1. So here the value computed as 1. Now we are going to compute the value of C of I minus 1 comma J minus Wi. 2 minus 1 is 1, J is 3 minus weight of first item that is 2 plus profit value of first item that is 1. Here I've got 1. Here I've got 2 minus 1 is 1 and 3 minus 2 that is 1. C of 1 1. C of 1 1 is 0. 0 plus 1. So 1 and 1 the proper value is selected as 2. So the maximum value is 2. Answer would be represented as 2. So the time complexity of 0-1 knapsack problem is big O of Nm, where N is the total number of items and M is the capacity of the knapsack. Thank you.